This video is for F1, force and momentum. Momentum is the product of mass and velocity, and it is in the direction of the velocity. If the mass is measured in kilograms and the velocity in meters per second, the momentum is given in kilogram meters per second. Impulse is the change in momentum. For a body of constant mass, impulse is the mass multiplied by the change in velocity. The change in velocity is the final velocity minus the initial velocity. Impulse is also a vector, and it is in the direction of delta V. Newton's second law tells us that the force on a body is proportional to the rate of impulse. If force is measured in newtons, impulse is measured in kilogram meters per second, and time is measured in seconds, then F equals the impulse divided by the time. It's important to note that the F here is the resultant force on a body, and the impulse is the resultant impulse. The change in velocity divided by the time, which you can see here after we've substituted for the impulse, is also known as the acceleration. And that's where the equation F equals ma comes from. F equals ma assumes that the mass does not change. So here is an example. Calculate the force you need to stop a 1,000 kilogram vehicle moving at 25 meters per second in just 0.2 seconds. We know from Newton's second law that the resultant force is proportional to m multiplied by v minus u, all divided by t. We substitute our numbers, being very careful to make sure we know what our initial and final velocities are, and then we perform the calculation. Be aware that with this calculation, the force is going to be negative because the force is slowing the body down. Therefore, it's acting in the opposite direction to the initial velocity of the body. And that's everything you need to answer these questions about force and momentum.